Assalamu alaikum my students, Answer here, welcoming you again to our another unit, that is differentiability. We have just completed a unit that was continuity, and I am hopeful you must have given your full concern to that unit, and every topic that is present in the unit continuity you must be aware about everything. Now we will go for the definitions of differentiability. First of all, I'm going to give the analyzation of this differentiability on graph. If we have this y-axis and this is my x-axis, if I have a function f of x and we know that this function is actually the curve, so if that curve is like this, and if this curve is now like this, if I have a point here C, like this, if this is my point x is equal to C here, and we know that corresponding to this point, the coordinates of this very point must be like this, C and f of C. It's my curve, and if I will take another point here, so the point C here on x-axis, and this is my y-axis here, and it represents the values of f of x, and on this number line we are giving the values of x. Now if I will take another point corresponding to this point C, and I will take it as x, so here this point will be x and f of x, so it will be like this. Now I have here the distance from this origin to this point. I have that distance equal to x, and the distance from this point to this point I have that equal to C. Now if I will subtract from this distance x this distance C, I will get the distance that is between the C and x. So this distance is equal to actually x minus C. Here this is x minus C. So here the distance, that is, if I draw perpendicular from this point, here I will take it as P, and this one I will take as Q, and this one I will take as M. If I will draw a perpendicular PM on this line X, and now if I join these two by a line, this P and Q by a line, this, so clearly this PQ is now chord of this function f of x. PQ is chord of this function f of x, and this PM is perpendicular, and the angle that we know that the perpendicular makes angle 90, so here it will be angle 90. But we have given the coordinates of this Q as x comma f of x. Epsilon is x and the coordinate is f of x. Now this PQ is now the line joining this point P and Q. Now clearly from this you check here this triangle PMQ, here this PQ, if I will find out the slope of this PQ, we know that the slope of a line is actually the perpendicular divided by this base. So here I have to find out this one also. In order to find this slope of this PQ, I must have the distance QM and PM. PM we know that is equal to x minus C. But what is the distance this QM? This QM we have this as point, after here we have this as f of x, and after this point we have f of c, so that means here it is f of c, the distance this p c is f of c, so here it is this x is f of c, so after here it is f of c, but the whole distance is f of x. So when I will subtract it from this qx, the distance this qmx, I will get the distance qm, and that will be equal to, now qm will be equal to, now yes, f of x minus f of c. So now I have a distance this qm given, and I have also a distance that is this pm given. Now we know that the slope of this pq, that is equal to actually this, if this is my angle theta with the x-axis or with this, and we know that the slope of the tangent is actually tan theta. So here slope of pq is actually tan theta, what theta is the angle. You know that slope of the line is actually tan theta, where theta is the angle that line makes on axis. So here it is now theta, tan theta, but we know that it is equal to perpendicular divided by base. So here what is perpendicular actually? That is qm, so it will be equal to now qm divided by this pm, and it is equal to here qm, we have that equal to f of x minus f of c divided by f of x minus f of c divided by this pm, but this pm is x minus c. So I'm getting the slope of this line PQ equals to this chord. Actually, this is the chord, or I can say this is also secant to here PQ, and I'm getting its here. I'm getting its slope equal to f of x minus f of c divided by x minus c. But now, if I will make this point Q tending to this P, or if I will this here is if I will this here it is x. If I will make this x tending to the C, if I will approach this x to C, so that means if I will this point, if I will take this towards this P, what will happen, beta? This PQ, when I will take this Q to this P, towards this P, this PQ will become actual tangent. This will not remain now secant. When I will approach this Q to PQ, it will become tangent now. So here, when I will give x tends to C, this limit x tends to C, slope of PQ, that will become slope of tangent. So I can say now here slope of tangent, slope of tangent, slope of tangent, because when I will take this Q to this P, this PQ will become at that time tangent of this axis. So slope of tangent of f of x is equal to slope of tangent of f of x is equal to limit x tends to C. This is slope actually when I will tend to f of x minus f of c divided by x minus c. So here it is a tangent, PQ becomes the tangent at this point C, or I can say PQ becomes the tangent of curve f of x at point C. So here slope of tangent of f of x at x is equal to C is equal to limit x tends to C f of x minus f of c divided by x minus c. So I am getting here I am getting slope of tangent at x is equal to c to f of x. I am getting that equal to limit x tends to c f of x minus f of c divided by x minus c. So here It is the slope of tangent of f of x at this point c. Now, if this limit exists, then this slope of tangent, it is called the derivative, or it is called the differential coefficient of f of x at point c. Now, I am saying you, if this slope of tangent of this f of x at this point x is equal to c, if it exists, then we first say that the function is differentiable at this very point c. And when it is differentiable at this point c, we say beta when it's a differentiable at point, we write that differentiable coefficient or that derivative is equal to this very thing, and we write that with equal to f dash of c. That means that denotes the derivative. That means the derivative of this function f of x at point this c, that is equal to this limit x tends to c, f of x minus f of c, x minus c. So our definition is like this: a function is said to be differentiable at point x is equal to c if and only if the limit x tends to c, f of x minus f of c divided by x minus c exists finitely. And we denote that equals to f dash of c, and this is called the differential coefficient of f of x at c, or derivative of f of x at c. This is my definition of derivative. Now, we know that this limit x tends to c, we know that this limit we can make it as left hand as well as right hand. We know that this limit x tends to c means the values of x are either less than c and are approaching to this c, or they may be the greater than c and also approaching to c. So when I will talk about the values of x that are less than this c, so at that time I am actually talking about left hand, and this limit x tends to, we denote that left hand equal to c, ऊपर हम माइनस डालते हैं, that means left hand, and f of this limit f of x minus f of c is divided by x minus c. At that time, if this exists, this is called the left hand derivative of f of x at c, or this is called the slope of tangent from the left of c, slope of tangent to the curve from the left of c. And similarly, this limit x tends to c positive, f of x minus f of c divided by x minus c. If this one also exists, then we say that this is the right hand derivative, or we say that it is the slope of the tangent of f at point c to f of x from the right. So these two. So and now we will write the definitions of this. So you just make this graph, and I am hopeful that you must have understood this very limit and this slope of tangent, how it is possible here. So now I am going to define it. I am going to write its definition. But this unit is very beautiful again, but you have to make your mind totally engaged with the every concept that is in this unit. So after that, you will really enjoy the mathematics. So here you write first a function f of x is said to be differentiable at point x is equal to c if and only if limit x tends to c, f of x minus f of c divided by x minus c exists finitely, or this limit x tends to, we know that this limit exists only if and only this limit exists if and only if the limit, left hand limit and right hand limit exist but are both equal. So I can write this as limit c negative f of x minus f of c divided by x minus c equals to limit x tends to c positive f of x minus f of c divided by x minus c is equal to L, where L is finite. Or again, by the substitution method of this limit, we can take this limit to as tends to 0, and this we will give the value of this x as c plus h. We know that by the substitution method. So this will be also equal to limit as tends to 0. This is f of, it will become now c plus h minus f of c, and here it will be c plus h minus c plus h minus c. So c and c will get cancelled. It will be here h exists finite. So either you have to check this limit as tends to c f of x, or you have to check this one. So it is now up to you. So similarly, you can do the same procedure with this limit x tends to c negative f of, you can follow the same procedure here. You will give the limit as tends to c as positive. Here we know how this c negative becomes as positive. The limit as tends to 0 positive f of x and f of this thing, you will get there, and similarly you will. So and x finitely, and we denote it by f dash of x, f dash of c, f dash of c, f dash of c, where f dash of c is called derivative of f of x, or differential quotient of f of x at x is equal to c. So you write here hence differential quotient or derivative of f of x at x is equal to c is f dash of c equals to limit x tends to 0, limit x tends to c, f of x plus f of x minus f of c divided by x minus c. So this is the definition of derivative or differentiability of a function at a point. So the condition for function to be derivative is that limit x tends to c, this thing must exist. So we can say after the function is differentiable at that point. So you write another definition. A function is said to be differentiable. A function is said to be differentiable function in an interval this a comma b, open interval, in an interval a comma b, if in an interval a comma b, if and only if the function is differentiable at every point that is in this interval a. So I can write here if and only if for all c belongs to a comma b, while this is arbitrary, c belongs to a comma b, limit x tends to c, f of x minus f of c divided by x minus c exists finitely. So this is another definition. You write the third one. Write the third definition now. A function is said to be differentiable in an closed interval a comma b if and only if. Now I have a closed interval a to b. I have to define the differentiability of a function. This function f of a function is said to be differentiable, and you write f of x is said to be differentiable in a comma b if and only if first f of x is differentiable in all the points that are between this a and b. Second, f of x is, here you check, I have to include the points that are approaching to this b but are from this left, not from this right, because when we will go towards the right, when we will give the values of the x towards the right of b, they will not get included in this interval. So I have to define the differentiability only from the left. So if and second one is f(x) is differentiable from the left of this b and from the, now here, from the right of a. So this is my another definition. Now you go for one more definition. Left and derivative. Left hand, I will write in short form. Left hand derivative of f of x and c is denoted by f this c, like f dash of minus this c, and is equal to f dash of c equal to limit x turns to c negative f of x minus f of c divided by x minus c. Similarly, you have to define the right hand limit. That's not easy. You write it by yourself. So this was all about the definitions of this differentiability. Now you write down the theorem. That will be our last topic for today. That is, you write theorem. It is very beautiful result. Prove that if f of x is differentiable, then f of x is continuous also, but converse is not true. Theorem says that if we have a function that is differentiable, if prove that if fx is differentiable at x is equal to c, then fx is continuous also at x is equal to c. But converse is not true. The theorem says if we have a function and the function is we have continuous at some point x is equal to c, then the function is differentiable at point x is equal to c. Then the theorem says function is also continuous at that very point. But if the converse is not true, that means if we have no continuous function, it is not necessary that the function must be differentiable. So differentiable means continuity, but continuity never always means differentiability. So this is our theorem. So you write down the proof. Let f of x be differentiable at x is equal to c. So when this function is differentiable at x is equal to 0, c, then therefore limit x tends to c f of x minus f of c divided by x minus c, it will be equal to then L. Finite value, because when this exists and is equal to finite, then L, where L is finite. So if this thing happens, now limit x tends to c f of x minus f of c equals to, can I write this limit x tends to c f of x
चुन चुन के निशाना लेते हैं, हिलने का न मौका देते हैं। हम मौत है एक दुश्मन के लिए, दुश्मन को फना कर